All right. We are good to go. Dr. Tanvi, over to you. You can please start sharing your screen and begin this webinar.
Okay, Pranav, thank you very much. Could you just confirm if my screen is visible, Pranav?
Yes, yes, it is visible. Absolutely.
Okay. Okay, great. All right, so to all the teams, welcome to today's talk. I promise you that this one's going to be interesting. The topic is very interesting. It's about payloads for the SUCAV, that is the supersonic UCAV, which you will be designing for your NACDeC problem statement. The objective of this talk is going to be just to give you an idea of what's going on out there, what payloads are really being used out there. And then at the end of this, we will give you some sample payloads which you need to use for your design problem statement, right? This is how I look at work. That's my work wear. My name is Tanvi Prakash, and I work at L&T Defense as Assistant General Manager for Unmanned Systems. I'm basically an aircraft designer. And at L&T, I work in the area of aircraft design. And I'm also a test pilot for jet-powered UAVs, which L&T builds for the various Indian armed forces. I completed my PhD from IIT Bombay just recently. And I have a mechanical engineering BTech from VJTI Mumbai. And I have actually done my master's and PhD sponsored by L&T at IIT Bombay. And on the management side also, I've been to Harvard and I have a few awards under my belt, which you can see. And because I'm in a part of the Aeronautical Society of India Design Division, I'm a member of the executive committee here. And I also love Indian classical music. But this is going to be about payloads, right? So I'm going to talk you through what these payloads are, and then I'm going to link it to your problem statement. What exactly the payloads, how exactly are these payloads derived from the mission profile? And then there will be a segment at the end where you can ask me questions. Okay, so I would request you to just hold on to your questions until the end of the talk. The talk will last for about 45 minutes or so, after which we'll be open for questions. The word payload, if you just look at this word payload, it's made of two parts. It's pay and it's load, right? So what is it really? It's the load that you pay for when you design or build an aircraft, or when you say buy a ticket to go on a flight. You're paying because you are load that's being carried by the aircraft, right? So that's what payload actually means. What you're basically paying for the aircraft for, right? Now, when we talk about unmanned combat aerial vehicles, UCAV, before going into what exactly payloads are, I just want to show you what an typical existing UCAV looks like. Okay, the one in the photograph is the US Air Force XQ-58 Valkyrie, an experimental UCAV, which weighs around 12,000 pounds, has a payload of around 600 pounds, cruises at an altitude of 40,000 feet, has a maximum Mach of 0.85 and a wingspan of around 22 feet, which is around 6 to 7 meters. There are quite a few UCAV that are out there. I'm sure as part of your work for NACDeC, you have been looking around at what all UCAVs are there. I've tried to represent UCAVs from various parts of the world. The top three are from Turkey, and the bottom two are the Predator and the Reaper, the very well known and one of the oldest UCAVs that have been around. And in fact, just today when I was reading the aerospace news, this is the new kid on the block, the latest UCAV, which has been released just a few hours ago by the US Air Force. This is the first photograph of it which has been made public. This one is called the YFQ-52. Now, if you can observe all of these UCAVs, they look a certain way, right? They're long and slender, and they have, long slender wings with high aspect ratio. But then there's a whole different class of UCAV which looks like this. These UCAV are what are typically called the stealth UCAVs. These are very high speed, sometimes supersonic. So the ones that you're seeing in the image, I don't know if you're able to identify them, but they all look like a triangle, like a delta wing, but actually if you look at it, they've all got features that which are very unique to each of the configurations. For example, if you see the center top one, you can see that's one of the US Air Force UCAVs. And from the top right, you can see there's a refueling boom that's coming in and trying to, engage with this UCAV to refuel it and increase its range. Each of them has unique, requirements and design features. But the common thing to all of them is they look like this blended wing body kind of configuration with a delta wing or, different types of variations on the delta wing. Now, why is this? This is because these UCAVs, also if you'll observe, they don't have any vertical surfaces. They don't have vertical tails. When we say horizontal tail and vertical tail, the vertical tail is not there in all of these configurations. They're tailless. Now, the reason for this is they want to be stealth configurations. I'll just go back to the previous slide. You can see all of these have got vertical tails. You can see they have a V tail. But the ones in this slide, they've got no vertical tail. So they are meant for stealth because radar signatures are higher when there is a vertical surface that radar can reflect off. So you are more detectable to enemy radars when you have a vertical surface. That's why they have tried to minimize the vertical signature of these shapes and maximize the horizontal planform. India is also not far behind. We also have our UCAV. This is a recent public release of one of their images of their planform. So they are also going in the same direction as this tailless delta wing kind of a UCAV. I want to draw your attention to the fact that so far, all of these can go up to, they push the limit of speed only up to around 0.95 mark. So far, none of these which have been developed are supersonic yet. But all of these companies represented here, there is Boeing, there's British Aerospace, there's Northrop Grumman, there's Lockheed Martin. All of them are working on supersonic versions of these same UCAVs. So that is kind of like your problem statement. Now, when we talk about payloads, in this case, it's a combat aircraft. The C stands for combat. So there has to be some payload related to combat. That's why you're building the plane, right? So you can see where these payloads are located. For example, in the image on the right, you can see that the payloads, which are actually these missiles, they are located on the bottom surface of the wing and also under the fuselage, right? But they are located externally to the aircraft. They are not located inside the body. Whereas in the UCAV shown on the left, which is one of the Boeing models, this is a Turkish model. This one doesn't have anything under the wing. There are no external payloads visible. Everything is located within the payload bay, right? So these are called underwing payloads and these are called internal payloads. Now, what is the reason for this mainly? So again, the answer lies in stealth, first of all, because the more things that you have outside, the more you're increasing the reflections for radar to pick up. And of course, since the designs like the ones on the left, they are trying to push the envelope of speed, it's always better to minimize your drag by having as few external payloads as possible. You want a smooth, sleek shape, which is, aerodynamically efficient. And that's, all the other payloads are accommodated inside. When you want to release a payload, you open a hatch, release the payload, and then close the hatch again and fly off. So this is what actually it looks like. If you look at, let's go one step back. If you look at the image on the right, this is how typically a payload is launched. Okay, I'm going to refer to all these missiles, bombs, rockets. I'm going to refer to all of them as just the word payload. So when this payload is launched, it basically ignites It's dropped from the wing, and then it ignites a rocket which further propels it forward and clear of the aircraft. That's how it shoots the payload out, right? But when you have a internal payload bay, this is what it looks like. You can see the bottom left image. That's an image of the payload bay. You can see it's open now, and the payload has been fired, and now the bay closes back, right? And on top, you can see even if the payload is not fired, even if it's just dropped, so it can also look just like this, where several payloads are dropped in series from the internal payload bay. Now coming to what exactly we need to carry, right? So the payload, we have already seen how these payloads can be deployed. But what are they actually? The answer lies in this image. You all will identify this image. It is from your NACDeC problem statement. This is the mission profile that has been given to you. So I want to draw your attention to a few features of this mission profile, okay? And that's where the payload is going to evolve from. This entire mission duration is 1 hour. Okay, so from the time of takeoff to the time of landing, that time is 1 hour. The second important feature, the onward cruise and the return cruise, both of these are taking place at an altitude of 14 kilometers. Now, the third feature, and this is where I really want you all to look carefully, you've been given a distance from the base of 1,000 kilometers, right? It's a one-way distance, 1,000 kilometers. You have a strike at 1,000 kilometers, and then you return back another 1,000 kilometers, right? This is a problem statement that's been given to you. So that means your target is 1,000 kilometers away, which needs to be struck with a payload. The next feature I want you to notice is the strike itself. The strike itself, this phase, it's occurring at a lower altitude. Your cruise altitude was 14 kilometers. It's occurring at just 10% of that. It's occurring at 1.5 kilometers altitude. It's a low altitude strike. I'm going to come to why in some time. The other important feature is the cruise phases, the onward and return cruise phases are both supersonic. However, the strike phase is subsonic. Okay, this means that you want to be able to take off as fast as possible, cruise as fast as possible, and cover this entire distance of 1,000 kilometers as fast as possible. Then, when you drop the payload, it's dropped at a subsonic speed. And then, as soon as the drop is complete and the attack is done, and then you come back and at the best possible speed, at the max possible speed, and then you return to base and land back. So these are the features of the mission profile which I want you guys to keep in mind for the rest of this talk. Just to give you an idea of what a 1,000-kilometer radius looks like. Okay, I'm not going to get into too much detail about this, but for us, for the Indian context, this is what it actually means. Now, if you look at the various mission roles for unmanned combat aerial vehicles, typically these are the 4 roles that UCAVs are performing these days. Okay, the first one is tactical ground attack. I want you to see this word, tactical. The second word is strategic ground attack. These two are ground, air to ground. Okay, the third one that you see is air combat. It's air to air. And the final one is electronic warfare. Okay, this one is fairly recent. This is maybe like, the last 20, 30 years, it's really picked up. But the first 3 are as old as fighters themselves. Since the times of the World War, ever since planes have been used in battle, these 3 roles have been the primary roles that aircraft, attack fighter aircrafts have been, serving. So I'm going to get into each of these now. I hope everyone is with me so far. When we look at tactical ground attack, what does this really mean? What this means is you are attacking in support of ground troops. So there's somebody on the ground who's gone ahead into enemy territory and they need some support or some cover from the air to protect them while they are doing their mission on the ground. These targets are usually time sensitive because ground troops always work on a highly timed basis. Like, for example, at 3 o'clock at night, the strike has to take place, right? So it's very time sensitive target. The other thing about these attacks is they are always precision. They are targeted against single vehicles, single, military equipment, single buildings, sometimes even persons, as in the case of the anti-terror strikes by the Predator UAVs, where, Osama was taken out. So precision, you don't want to strike anything which is not intended to be struck. Okay, that means no collateral damage. And usually these are not very deep in enemy territory. Reason being, your ground troops have to reach that far, right? So for ground troops to be able to get that far, you cannot infiltrate very far without being detected, right? When you're moving on the ground. So these aircraft are usually providing cover to ground troops, not too deep in enemy territory. Typically, a scenario looks like this. There's a tank and some of our ground troops, some of our vehicles and soldiers have gone in to break the progress of this tank towards our territory, perhaps. And that's where the UCAV comes in. And the UCAV drops a tactical payload and is able to neutralize the tank or at least disable the tank while the ground troops come in and then, take captives or destroy or whatever is, needed as per that mission. Typically, the payloads look like this. They are anti-tank guided missiles. They could be laser-guided rockets. They could be mini micro munitions, or they could be precision-guided glide bombs. These are the 4 categories of weapons which come under this tactical category. And in reality, this is what they look like. You can see they are quite small. Small on the scale of other ammunition. So just I want you to note, this is about 1.6 meters and 1 meter length. Their range is also relatively small, around 10 kilometers, 8 to 11 kilometers is the range in which most of them are able to cover on the ground from the air. And their weight is also fairly light, 6.5 kilograms, you can see the one on the right, and 45 kilograms, the one on the left. So it's something which maybe 1 or 2 people can easily lift and, fix onto the launcher beneath the aircraft. And the aircraft can, then take it from there. The one that you're seeing here, the AGM Hellfire, this one is actually currently mounted on underneath a wing. Remember that image I showed you of under wing mounting? So this is called a pylon, and this photograph shows it's cropped, but you can see the bottom surface of the wing over here. And there is a structure here called the pylon with a launcher on it, onto which this has been strapped. So typically, this is how it works. But it's not necessary that these have to be under wing. Sometimes they can be inside an internal bay as well. Okay. Now, these are the 2 popular ones which have been used in the last 10-15 years in UCAVs for tactical conflicts. Just to go a little deeper, what's really inside these, actually? So, of course, first things first, the warhead itself. That's basically the explosive part. That's the part that hurts. It does the damage. Then there is the propulsion unit. You can see this at the rear. I'm also going to point to it. This is the propulsion unit at the rear. And that is basically some kind of chemical rocket or some igniter or some kind of mini engine which is at the back, which propels the payload forward. Then there's a control unit. This is a system of motors and fins. These things are called fins, which can be deflected to control the direction in which the payload is moving. And how do you know where you're going? With the help of this laser seeker. So there is a nose in the image that you saw before. I don't know if you observed it, but there was a kind of black nose on the front. That's actually a window behind which there is some kind of a seeking device which will tell this payload its location. with respect to the target that it's supposed to hit. So it's able to really do precision attacks because of the presence of this laser seeker. So what happens is the laser is located on the aircraft, and the aircraft will shine a laser on the target which needs to be hit from far away. And this little seeker, it's like a cat following a laser, right? If the laser moves, then this thing will also move with it and exactly go and hit the spot where the laser is being shown. And then how does it know when it should make a blast? That is through the fuse. So the fuse is usually some kind of an impact device. So when there is a sudden contact, or a gentle contact is not enough, by the way. It has to be a sudden impact contact. When it finally hits the building or hits the tank, that's when a shock is observed. And that shock triggers the fuse and creates the chemical reaction which will cause combustion of the warhead inside. So that's how this thing works. Now I want to again remind you of those two words, tactical and strategic, right? So we've spoken about tactical ground attack and strategic offense. I'm showing the map of India because it's something that we all can relate to, but this is not an Indian context. It works for all the UCAVs in the world. A tactical attack is something similar to what happened last month, right? The 4-day war, the 100-hour war, which happened. That was a tactical attack where there were specific ground locations which needed to be neutralized and which were, precision attacked. Whereas the word strategic refers to something which is much bigger and it is much deeper in enemy territory, as you can see. And it is also on a much. This really means I'm going to detail it out over the next few minutes. What is a strategic attack? In this, what happens is it's usually a standalone mission. Like what you saw in the recent operations by India, there were several missions. There were several locations which were identified and several places which needed to be, precision neutralized. But when you look at a strategic attack, it's usually standalone. It's one critical installation located deep inside enemy territory. Okay. It could, for whatever reason, it could be a military base, it could be an airport, it could be a political building, anything like that. These are usually larger targets. They are not so precise. You don't need to be that precise. You need to be precise. Yes, you shouldn't hit the bazooka building. It has to be fairly precise. But these are usually much larger targets requiring a much larger amount of explosive material to destroy the target, right? You don't need much to attack a terrorist. You don't need much to, say, explode a tank. But if you're talking about a gigantic building, then it's going to need a lot more, booms to take out this target. And usually it is on a larger area. So it's like a building complex or, convoys, large trains of vehicles that are traveling. And they are also, the most important thing is they are deep in enemy territory. Okay. Now, the moment you say deep in enemy territory, so many design issues crop up. How do you get deep into enemy territory? So you have to be able to fly that deep into enemy territory. But it's not like everybody is going to let you go so easily. The moment you cross the border, there are going to be radars that light up and guns who try to shoot you down. So you have to avoid all of that. And that's where stealth comes in. So most of the stealth UCAV which I showed you are of this kind, which can go where they are not supposed to be. The first kind of UCAVs which I showed you, which were those long, slender wings, those very rarely go into enemy territory because they are easier to detect than these kind of stealth vehicles, right? So those will probably stay inside inside our boundary area. Like, for example, they might be just hovering over this border somewhere here. And remember that 8 to 11 kilometer range that I told you about. So they will fire one payload which can go 11 kilometers deep into this zone. Or maybe they'll just venture a little deep inside where there is no enemy protection. And then they can, fire their targets at 11 kilometers and then return. Whereas the strategic ones, they are supposed to traverse the entire distance and go all the way here without being detected. Or here, I mean, I've just taken the example of this circle, but I could take the example on this side as well, where the tactical strikes are mostly in this region. But there isn't much over here. It's just mountains here. But the main targets which are of interest are actually deeper inside enemy territory, which is in this zone. So that's the value of a strategic attack. Okay, and that's the main key difference between strategic payloads and tactical payloads. So strategic payloads, which look like this, are air-to-surface missiles, drop bombs, like the kind, remember in the photograph, in that moving image with which was just spewing out bombs. So those are drop bombs. You just open a bay and they just fall out. And then you have guided bombs. Guided bombs are basically with a seeker, like a drop bomb with a seeker in front of it. And then you can also have ballistic missiles, right, which are much more powerful, much heavier, and much more destructive also. Typically, these are the popular ones that are there right now. The GBU Paveway is one of the popular ones. And the Indian version of the strategic ground attack weapon is the Sudarshan, which is developed by DRDO. Now I want you to look at the size of these. Okay, remember the previous one was 1 meter, 1.5 meters. These are straight away double, triple. They are 3 meters, 3.7 meters. Their range is also now triple. Going from 10 kilometers, now the range is much deeper. Okay, because they will glide for some distance before they hit their target. So why do we glide? Because you get better aerodynamic efficiency. So you can get like a 30-kilometer range. The aircraft can be even 30 kilometers away from the final target. It doesn't need to actually go above or so close to the target and drop these weapons. It can stand off at a clear distance and then send it out. And now the important thing, look at the weight. So previously we were talking about something which 1 or 2 people can lift, 10 kg, 50 kg. The weight has now gone up to 450 kg. It's a pretty large weapon, actually, if you think about it. It's not very apparent from the photographs, but these are huge. Imagine 3 meters. 3 meters is double of my height. It's that big. So what's really inside these? The photos that you see on the left are the American series of glide bombs. These are called the Mark 82, Mark 83, Mark 84. So they are just dumb bombs. When we say dumb bombs, what it means is they don't have any intelligence, actually. They are simply dropped from a moving platform, and wherever they go, they will go and hit. So the moving platform has to be very precisely positioned before you drop this payload. If the positioning is not right, then the payload will hit Bajuka building, right? So they have to be, the flying has to be very precise in this case, when it's just a glide bomb. So what people did, they said, okay, we can't put so much load on the pilot, especially when they are so deep in enemy territory. There's so much pressure at that time, and usually your communications are also off, so they don't know where they are. So there's something called a kit, which can be attached onto these glide bombs. So you can see this thing is the shell of the glide bomb itself. This is the same thing. The same warhead carrying part is the same. And then there is a part which is added on the front and a part which is added on the back. And this front and back stuff is the same as what we saw on the smaller category. Basically, the rear area, these are moving fins usually, which with a motor assembly inside, and they can be used to stabilize and guide the payload. And the guidance is done using some kind of optics or some kind of GPS or some seeker system up in the front. And then there's a small system bay where all the computer and the avionics and the batteries, etc., can fit. And sometimes there are some control fins up front as well. which you can see in this. So these are also, it's a second set of control fins in this case for stabilizing stability and control both. So now we've looked at the small ones, we've looked at the big ones, the tactical and the strategic payloads. And now we'll move on to the air-to-air. Okay, so far we've been looking at air-to-ground. Now we are going to look at the air-to-air role. The air-to-air role is called also dogfight in pop culture. This is what you'll see in the movies, because air to ground, frankly, it's boring. When there are two aircraft flying in the air, it's so much more exciting. So you'll never see air to ground in the movies being glorified, but air to air is always glorified. Remember Top Gun, if some of you have watched that movie. This is basically a way of establishing air superiority, that I own and I control this airspace, and that's why enemy aircraft are not allowed, and I'm going to attack you if you're in my space. Right? So it's usually a show of superiority. Usually it occurs very close to the borders, because large aircraft don't go very far without detection. So this is usually roles, payloads which look like, which are actually air-to-air missiles, or sometimes they are even decoys, So these missiles sometimes have a heat seeker up in the front, which can actually seek anything hot around it. And the hottest thing around you in an air combat is actually your enemy's engine. So if you can just lock onto the enemy's engine, which has a temperature, a core temperature of thousands of degrees, and then you just, let this missile go and seek it and then explode near it. So what tactics can be used in air combat is you create another heat source, which is almost as hot. So basically you release Diwali ka fataka close to you and then you run away from it. So those really hot, sparks which are visible, that's where the missile thinks you are, and it goes and explodes over there. So you can save your life by doing that in a dogfight. You can spray some sparkly stuff, and I'm just saying it in these words, but actually it's these are called flare and chaff dispensers. So they are these are also some types of payloads which are typically used in air-to-air combat, and this is what they look like. Again, similar kind of construction, as you can see, the same old stuff, fins at the back, sometimes fins in the front, which also move. And then a seeker in the front, which is a thermal seeker or a laser seeker, perhaps different types exist. And then the exploding bits over here, the impact fuse over here, and the rocket system over here. It's the same construction pretty much. And this image, the one on the left, is one of the most popular recent air-to-air weapons used for UCAV. It's been extensively used on some of the American UCAVs, and has been very popular, has been very successful in terrorist strikes conducted by Americans. And it's named after a snake. The Sidewinder actually is a snake. If you've ever seen snakes, they actually they don't slither straight forward, they slither sideways, right? So they undulate and slither. So this particular missile also has a motion which kind of looks like that, and that's it's there to maintain its stability. So that's why this has got the name Sidewinder. And the one on the right you can see is one of the new latest weapons which Turkey has come up with, which was also, we don't know, but which could have been used in recent conflicts, of last month. And now I want to again draw your attention to how big these are. Okay, they are air to air, but they're still pretty large. They are 3 meters in length. And their range is also, in fact, pretty large, because this is the range at which a pilot might be able to see the enemy aircraft. So if you the quicker you are able to neutralize threats, the easier it is for you to win your dogfight. So if the threat is 25 kilometers away and you're able to take it out, good for you, right? You've already won the dogfight rather than having a close range combat. So now, again, look at the weight. The weight is not as heavy as the glide bomb category, which you saw previously. These are a little lighter, on the lighter side. But of course, these examples that I've picked are on the lighter side. There are also heavier air-to-air missiles out there. And many of these, by the way, the air-to-air missiles especially, are actually adapted from the ones which are used on fighter aircraft. So the Sidewinder, the initial early versions of the Sidewinder actually were developed for legacy US Air Force aircraft, and now they are at a stage where they are also being used on unmanned aerial vehicles. So this makes complete sense because mostly it's the fighter aircraft which have been involved in air-to-air combat. They are designed for air-to-air combat, and very few UCAVs are. At least I'm not aware of a dogfight that has yet occurred between two unmanned aerial vehicles, but analysts say that the day is not far when that will happen. There are claims that have been made, but they are quite unfounded and mostly just there for their excitement value. But we don't know, honestly. If there has been, then it's not out in the public domain. But this is something which also the future UCAVs would, it's a feature that they would have. I think I'm experiencing some network issues. Could Pranav please confirm if I am audible?
Yes, you are audible. It's all
Okay.
perfect.
Okay, thank you. Now coming to the final kind of warfare, which I said, that was electronic warfare, right? Sounds cool. This is basically, the technical word for it is suppression of enemy air defense. What is air defense? Your enemy has some equipment which protects them from you attacking them from the air. Right? I'm going to say that again. So when we go to an enemy as an air attacker, they should have some defense system in place, which is known as the air defense, right? So suppression of that is called suppression of enemy air defense. So you'll see this word SEAD a lot nowadays. What this basically means is you locate, first of all, they don't tell you where they're defending, right? So first you have to locate where their defenses are located. And then you need to destroy or neutralize them. Usually these defense systems, the first, they use the standard, detect, sense, and avoid kind of logic, you can say. So first of all, they're looking all the while, they're detecting and seeing if anything is coming close to them. They sense, they check whether you're a friend or a foe. If you're an enemy, then they will say, okay, avoid, and they will try to, destroy you. So the first step itself, at the detection stage itself, it's best to suppress these air defense equipment. So usually how they detect you is through radar. There are, of course, different ways of detecting also. There may be some, acoustic means or visual means. There are many other ways. But the primary way that most countries use is radar, because radar is long range. You can detect something coming from very far away, sometimes as far away as 50, 60 kilometers, you can detect something. Just to give you a context of that, on a very clear day, think of the clearest day you've seen in your life. The maximum distance on ground that you can see is probably maybe you've seen a plane, flying in the air above you. The maximum distance that you can see is probably around 15 to 20 kilometers. For most of us normal people, and me with my specs, probably lesser. But maybe a trained fighter pilot can see about 20 kilometers away. 25 kilometers is what some people claim. But these radars, they are not in the visual range. The radar can see about 50, 60 kilometers away. So that's the advantage of using radars for detecting. So if you can jam the radar in advance and then enter their territory, the radar will be blind. They won't know that you're there. Right? So this is one of the tactics that can be used for strategic warfare. Remember, I said, if you want to go deep into enemy territory, you have only two options. Either one option is to not be visible at all. And secondly, if you are going to be visible, then you destroy their eyesight. You destroy their radar capability. So this is where electronic warfare comes in. So it induces a temporary shutdown of the radar. It overwhelms the radar system and forces them to reboot the system. It's kind of like when your blue screen of death happens on your computer and you can't do anything. You just have to, wo jam ho gaya, you have to restart your computer. There's no option. If you had some unsaved data, then, God save you. So that's exactly how it is with these radars. And when you induce them to shut down, the startup process after that, if you've ever had that problem of having to restart your computer, you know how long it takes, right? And now imagine a super complicated system, which is like a network of radars and guns and air defense systems. Imagine how long that thing will take to boot up, right? If it takes even 5 minutes for the radar system to come back up, 5 minutes is plenty time for a supersonic unmanned aerial vehicle to come and bomb you and go away. So that's where the electronic warfare payload comes in. And like I said, it's usually for warfare deep in enemy territory. What does this actually look like? So, of course, I've just depicted a radar antenna. You might have seen these kind of dish antenna, kind of square antennas rotating in the Republic Day parade and all. It kind of looks like this. Usually these are anti-radiation pods. And sometimes they also come with the feature of being able to actually like go and strike also. Like if the radiation thing fails, then there can be a command sent to it and it can actually go and destroy the, like shoot down and destroy the target. It's, usually the radar is just it's not the main target, but sometimes you actually do also want to take it out and just be sure that they can't see what's coming at you. So this is what typically radars look like. The one on the left is one of DRDO's recent NGARM developments, which has now been named the Rudram anti-radiation missile. And then you have the Russian, this is the most popular one right now in the Indian forces. Most of our Sukhois and all the other Russian stuff has this on board the fighters. So once again, you'll see that these are legacy fighter payloads. Actually, these weapons are used in the way a fighter would fly, like right, a stealth fighter usually, or a bomber or a strategic aircraft. Now again, look at the lengths of these. And you'll be surprised, although these are not, they are not just explosive payloads, but just the addition of this sophisticated electronics has now added the length. You can see it's gone up to 5 meters. The weight has also increased. It's gone up to 600 kilograms. The range is now massive. It's around 150 kilometers. So from that far away, you can actually release this electronic warfare anti-radiation missile. And then be sure, by the time you get there, be sure that the enemy air defense is going to be down and it's clear for you to attack, right? So that this is the electronic warfare payloads. So what's our supersonic UCAV's mission role? Can you think of why I've put a cross on tactical and why the other three are okay? The main thing, the main reason for this is our range and our speed. Because of a 1,000 kilometer range, it's quite obvious that this is a strategic role that something like this will have to play. It's not a tactical role. It would be a waste. I mean, it's not that you can't use this for a tactical role. You can, but it would be a waste when you can send us much slower, more benign kind of, maybe a much less expensive thing can be sent. Why would you send something that is capable of supersonic and capable of carrying so much payloads just for a small tactical attack, right? So you need to have these kind of aircraft, massive supersonic UCAV kind of aircraft for strategic attacks. And on the way, on your way in, if you are intercepted by anyone, be it a radar system who's trying to jam you, or be it an air-to-air combat, if another fighter or another UCAV comes to try to challenge you in the air, you need to be able to counter that, right? So this is basically why why the mission role, the mission profile that you've been given is not a tactical one, but a strategic one. So now the real question, what do we need to carry? Right? You all have all been listening very patiently to this talk to figure out this for your design requirements. So here it is. For strategic ground attack, remember the guided bombs we spoke about, the 3-meter kind of category. So these are the dimensions which you need to allow for within your payload bay. So in the image that is shown over here, this is actually the doors of the payload bay. Remember I showed you the weapons bay which was opening in the video which you saw. So this is that door which opens, and 4 of these are supposed to be inside. Don't go by the size of it. It's just a representation. These are actually going to end up looking much smaller when you actually put it into your CAD, but it's a representation. 4 of these size guided bombs of 250 kg each, because you have a 1000 kilogram payload. For the air combat role, you'll have to carry air-to-air missiles, 4 numbers of them. These are again the 3-meter range. And then the anti-radiation pod, because you may want to be able to jam enemy defenses. So the anti-radiation pod, since they are heavier, 500 kilograms, and a larger length as well. This is what the configuration looks like. So the center piece here, this payload is the anti-radiation pod, which is the larger diameter. And on either side of it, to balance the weight, are equally placed air-to-air missiles. Again, inside the openable payload bay doors. And finally, for the electronic warfare role, you would be carrying 1 anti-radiation pod and guided bombs along with it for your strategic attack, which will look like this, a 3 side-by-side configuration with the same lengths and weights which were there before. So these are the 3 configurations, the 3 payload configurations that you need to make room for while designing your SUCAV. Now, a little bit about these payloads. Now, you've seen that they have fins around them, they have some electronics, and they've got so much, they must be very intelligent. There's a computer, you need to be able to give a command to launch it. There's a launcher I showed you. So all of this occupies space, right? Inside, it's not like you just load these cylinders inside and your job is done. You need to give some space around each payload as a conceptual aircraft designer. So the idea is that you need to keep 20% extra space, which means if your diameter is D, you need to keep 1.2 D of space diametrically clear around that payload, right? So if your diameter is 100 mm, let's say, you need to keep a space provision of 120 mm around it. If your diameter is 50 mm, you need to keep a provision of 60 mm around it. Right? This is because it's not uniform for all sizes. Larger payloads require more space and smaller payloads require lesser space around themselves. Is someone on off their mute? Could you please check, admin?
Tanvi, you are the host right now, so you should manually, do this for Team Agnivesh Vivek Pal.
Okay.
Team Agnivesh Vivek Pal, you are not on mute. Please mute yourself.
Is the price doing this, the cost of entry, whatever the thing.
Please continue, Tanvi.
Okay, I have muted the person.
Next time, if they come back again, we should remove from the meeting, Tanvi. Next time, if they come again.
Okay. All right. So this is about the packaging. This is the space that is required around each of these payloads. And we are almost done anyway. The other requirement I just wanted to remind you all about was the low observable requirement. So select your payloads in such a way that they should be inside the weapon bay, not under the wing. Okay, they should be inside a conformal shaped weapon bay so that you can get your best possible aerodynamic characteristics. If you add too much of underwing weapons, then you're going to reduce your aerodynamic efficiency. And you're also going to get a lot of drag, especially when you're at supersonic speeds. And that leads us to the third point, that the payloads are not going to be released at supersonic speeds. Remember the mission profile? Onward cruise and egress cruise are supersonic, but the strike phase, which was at 1.5 kilometers, that is subsonic. So payloads are only released at subsonic speeds in that part of the mission profile. So if you are going to be doing any weight fraction calculations, or you need to account for the fact that the payloads are going to be removed in that phase and not in any other phase, right? So that's about it. And now it's time for you all to drop your questions on me.
So those who have doubts or questions should just raise their hand in the software, and then we will one by one. Then we will, take the questions. Or you can also type your questions in the chat window, which our volunteers will try to follow. Also, volunteers who are monitoring the YouTube channel should also share with us what questions are being asked there, if at all.
Okay, we'll wait. It looks like everybody has been taken out by these payloads. Strategic ground attack has happened. Nobody is asking questions.
No, they are digesting what you have very beautifully explained. It is an excellent way of explaining. I am remembering my HAL Nasik days when I used to work with these payloads.
You must have worked with these, na, sir?
Yeah, I mean, since nobody's asking the questions, I'll just share something. The last thing I did in HAL Nasik was to do the trajectory analysis of a runway denial bomb called BAP-100.
Okay.
BAP-100 was a Russian product, which was, it was a cluster bomb. So the idea is the pilot would fly diagonally across a runway, and before the runway starts, they will start dropping these bombs. So there will be a series of small bombs that will open out, and it will, so that we do not have a chance for the enemy to repair the runway, because these bombs were supposed to go deep inside, and sometimes there was a delayed fuse, so they will not explode immediately. They would be embedded, and then after 6 hours, 8 hours, they will explode. So this was to prevent repair of the runway in a short time by the enemy during combat scenario.
But
So
I
they were
believe this
yeah.
delayed explosion has been one of the reasons why cluster bombs have been flagged now, right? There are so many humanitarian concerns about the use of cluster bombs today.
Yes. So BAP-100 bombs were designed only for runway denial. Okay, so there is one question in the chat window which I will try to. Okay, you can.
Okay, the question is, do we have to design release mechanism of internal payload bay?
Yeah, I mean, I would like to answer the question. So this is something which is a second order effect. You need not really worry. Um, that is not a part of conceptual design. That is normally a part of the preliminary design. If you do it, it is fine, but it will be, I think, a waste of effort. So it will not get you any brownie points.
So can I add something to this? The weights which have been given for each of the payloads, that also includes some weight for the pylon and for the release mechanism as well. So you don't need to also account for any extra weight apart from the weight that's given.
Okay, there is a question from Harshit about the configuration of the payload. So should we have three configurations or any one of them? No, you have to design for any of these three roles. So your payload bay should be a superset of all these three, so that any configuration can be chosen by the armed forces for the mission. So you cannot choose one of the three. You have to design for the possibility of any of these three being executed, because the same SUCAV is going to be used for any of these three missions. It's not dedicated for any one mission.
Are there any questions
right.
coming in on the YouTube channel?
If there will be, then I think volunteers will type them out. Dedicated for yes. Ajit, you can. Team Vajra Ankur wants to know if we have higher payload capacity, can we choose some other configurations? Of course, if you want to carry more payload, you can. This is the minimum that we need. Now, if you are having higher payload capacity, you can choose any other configuration if you wish. But let me tell you one thing from my basic experience. I advise people not to carry more payload than minimum required because it is always going to come at a disadvantage on the all-up weight, on the size, on the engine. So you will never be able to maximize the objective function that we have given by going for higher payload. Because the more payload you carry, the larger, heavier the aircraft
Yes,
will
the
be.
payload is what you're paying for.
Yeah. And therefore, the you are paying for it literally. You are paying it for money also. You are paying also literally a price in the all of weight of the aircraft. So all of weight appears in the denominator, right? So it is going to reduce your objective function. So our advice to you will be that it is better not to go for more than 1000 kg. But if you want to try it out, it's up to you. We have a hard stop at 8 o'clock. I mean, I don't want this meeting to go very long. So if you have questions, ask them quickly. It's already 2 minutes past 8. So we will wait for just one more minute. Team Safira, Mangal has a question on the final design report. Okay. Uh, what might be the fidelity of structural component design and analysis? Okay, so this is up to you. It's a conceptual design exercise. So to the extent you can go for the fidelity. We don't expect you to do a detailed FEM analysis of the entire structure. That is not the possible, I think, within the capabilities and the time limit. But use whatever methods you can in conceptual design to arrive at the structural fidelity. So it's difficult to answer this question. There is a question from Omkar. A question regarding stealth capability. Uh, okay, I don't know. Suddenly it has disappeared. Okay, is it possible to use ground unit jammers as they require more power to operate, which is hard to use airborne? Or if possible, any new technology for airborne jammers we can use in our SUCAP? My suggestion to you, Omkar, is limit to what we have given you. Go for the size and the weight based on what Dr. Tanvi Prakash has shared. This webinar will also be available on YouTube, and we are going to also share on the WhatsApp group the details. My suggestion is don't go for any other more exotic kind of concept because then there is no level playing field. Everybody will assume everything and go ahead with it. So it's better not to go for any other exotic combinations. I think on that note we should close the webinar because we are on time. Okay, there is a question from Sagar from Team Markworks about would the center of gravity uh, shift caused by large or dynamic loads need to be considered? 100% yes. You have to consider. You have to consider. I mean, there is, and you are saying you would like to have techniques or guidance. Very simple. When you release the armament, that much weight goes away. So you now know where the remaining, the CG of the remaining aircraft is. There's nothing like any technique for that. You just need to calculate that. So CG will shift when the armament is released. And that's why the best thing to do is to mount the payload at a location just below the CG so that there isn't much change. Of course, it may not be in your hands because the location near the CG is at a great demand. We need it for housing the main landing gear also. So you will have to do some jugglery, and that is the fun and the beauty of aircraft conceptual design.
So Team Safira has raised their hand.
Yes, go ahead, Team Safira.
Hello. So I have two follow-up questions. on my previous question. So on the F5, it is asked to conduct sensitivity studies in terms of speed, altitude, and payload capacity. But as per the problem statement, the altitude and payloads are constrained. So is it to show only performance sensitivity, or is it to show like if we change all this, then how will our overall design change?
Listen, whenever we do aircraft design, we get some mission requirements. So we design for them, but we always request the design team to tell us the sensitivity. So whether or not you will fly at an altitude above 14, it is good to tell us if the altitude is 15, 5%, 10% plus minus, what is the effect? There's no harm in doing that. It is just to get a feel for the problem.
Okay,
So it is important for you to do sensitivity analysis even when the mission profile is finalized. So whatever is mentioned in the problem statement, kindly try to do it if time permits. Then somebody has raised
hello,
their hand.
I
Yeah,
have one more question.
go ahead.
Yeah, so in F4, it's uh, like we are supposed to do RCS versus drag. So is it like a trade-off analysis that if you have more drag, you might have a configuration where you have more drag and less RCS, and vice versa, or something like that?
That is exactly what is requested.
Okay, okay, thank you, sir.
Okay, so I think we should then say goodbye to each other. It has been a fantastic webinar. Exactly what was proposed. Uh, any further questions should be asked on the WhatsApp group that we have. People are not using that group for any queries. Hardly we get any suggestions or any queries on our email or as well as on the WhatsApp. So this is the time for you to do it. Team Garuda from wants to know, is it possible to give the results from ANSYS and OpenFOAM? Yeah, why not? Why not? Why not? We have no problem. We normally recommend and prefer open source software, but if you have a licensed version of ANSYS available, we have no problem in using ANSYS. But remember, if we find that your ANSYS software used is illegal or pirated, we are going to disqualify your team. It was made very clear in the problem statement itself that, in fact, your faculty advisor has given in writing as under signature that only licensed software will be used. So that's why we normally recommend open source software like OpenFOAM, but we are not insisting on that. So Dr. Tanvi Prakash, thank you so much for such an entertaining and also enlightening webinar, where you very beautifully covered all the aspects related to armaments on a military aircraft, including on UAVs and also the relevant ones for the supersonic UAV. This will set the ball rolling now for the students to design the UAV according to the requirements that you have mentioned. So thank you so much. Good night to everyone. We are going to now stop our webinar.
Okay, all the best to everyone. Bye. Good night.